This is lesson number 3 of organic chemistry. For this lesson, I will discuss about the alkenes. Let's understand what are alkenes. Actually, alkenes are unsaturated hydrocarbons with the general formula CnH2n. What is more important is these two terms, unsaturated and hydrocarbons. In the previous video, we discussed what are hydrocarbons and what are unsaturated compounds. Ge re bolela ka hydrocarbons, re no bolela ka compounds that contains only carbon and hydrogen. Re no bolela ka a compound e le gore e na le carbon and hydrogen. Let's see for an example. Mo re na le a hydrocarbon, because o ka lemoga gore this compound e na le only carbon and hydrogen atom. So re la gore this is a hydrocarbon. But for alkene, mo we are very specific. Re bolela ka compounds that are unsaturated. Unsaturated re no bolela ka a hydrocarbon that contains double bond. Ge o ka lebelela this compound, this is hydrocarbon but re na le a single bond. This is alkane, because alkane ke a hydrocarbon e le gore e na le only a single bond. So now e re bone example ya alkene. This example ke alkene. Re na le a hydrocarbon, because mo re na le hydrogen re na le carbon only. But now what is more important is gore this hydrocarbon e na le a double bond. Unlike the previous one, alkane, re ba le only a single bond. But as for alkenes, re na le a double bond. So the moment o ka bona a hydrocarbon e na le a double bond, e rela gore is alkene. But ke nyaka gore lemoge something that is very important. Ge o ka lebelela this compound or compare these carbons, lemoga gore these carbons e na le 3 hydrogens, 1, 2, 3 hydrogens, but this one in a only 2 hydrogen. O ka dira a mistake where o place another bond wa dira hydrogen here. This is incorrect. This is because a carbon can only contain the maximum of 4 bonds. So already we discussed it in our first video. Or a carbon it contains the maximum of 4 bonds. As you can see, this carbon in a 2 bonds, 3 and 4. So this is the maximum. It can contain a 5. So when now another hydrogen here, it's going to be wrong. This is because this is 2, 3, 4, 5. So when now only 5 bonds, so it's not possible. For this one, alkane, are only 4 bonds, because this is 1, this is 2, this is 3, and this is 4. So a carbon can only contain the maximum of 4 bonds. Even this one, 1, 2, and then plus this 2, and 4. So that is something very important about the alkenes. Another thing, alkene, alkene automaka 1 carbon. This compound ke methane wela under alkane, but a kgone gore alkene e ka ba le 1 carbon, because this double bond always is between 2 carbons, something like this one. So you'll never have a situation whereby only something like this. So it's not possible. So now let's focus on naming alkenes. This was just an introduction. So now we'll name the alkenes. So now let's see these compounds. I'll label this one first. This is alkene because there's a double bond, and then this is hydrocarbon. But more a straight chain. ga re ne branch, so re tlo focusa ka branch later on, but now let's see gore ge re na le a straight chain re name bjang. Remember gore this is not a branch. Hydrogens ga di form a branch. Branch di forma ke carbon and other atoms. For example, ge be le gore this is something like, and then mo wa ba le CH3, re la gore we would say this is a branch, but in this case ga re ne a branch, re no ba le a straight chain. So re tlo shumisha the same rules just like for the previous video. What is important mo gore re nyaka go identify the longest chain, but that longest chain re nyaka gore e contain a double bond the closest. Let's see gore krela bjang. Ge re counter these carbons, o mongwe a ka re this is 1, this is 2, this is 3, and this is 4. O mongwe a ka re this is 1, this is 2, this is 3, and this is 4. But let's see gore ke feng yellow is correct, because more na le the correct one. Based on what I've said, re nyaka gore a double bond e be the closest. Ge re counter the longest chain, re nyaka go obtain a double bond very early. Ge re ya in this direction, this is carbon 1, this is carbon 2, and this is carbon 3. O ka kgona bona gore our double bond re obtain in carbon 3, because this carbon e na le double bond. Re la gore double bond re obtain in carbon number 3. But now let's see ge le gore re ya in this direction. This is carbon 1, and this is carbon 2, carbon 3, carbon 4. But lemoga gore this first carbon ge re ya in this direction, this carbon e na le double bond. E re la gore ge re ya in this direction, our double bond re kry-a early, so re nyaka that direction. So re la gore the correct naming yo ba this one ge re ya left to right. So now let's see gore re tlo name bjang. Just like for the previous video, what is important, re nyaka gore re be le a substituent, and then re be le a root, and then re be le suffix. Remember gore substituent re bolela ka a branch, but for these problems ga re ne a branch, re la gore re tlo thoma from a root. A root re nyaka go tseba gore re na le how many carbons for the longest chain. For the longest chain re kwane gore this is 4 carbons, as you can see, 1, 2, 3, 4. And then for the reason ya gore ke 4, re la gore yo ba build. Remember gore already re discussitše gore 1 carbon ke eng, 2 carbon, 3 carbons, and so forth. 1 carbon ke meth, and then 2 carbons ke eth, 3 carbons ke prop, and then 4 carbons ke butte, and so forth. So now because re na le 4 carbons, re la gore this is going to be butte. Re la gore ke tlo re this is butte, but ke tlo tshwanela go ke gore ke be specific gore ke kry-a kae this double bond. This double bond ke kry-a in carbon number 1. So re la gore ke tlo re dash, and then ka ngwala 1, and then from there ka ngwala suffix. Suffix ke the ending name, because more dealer le alkenes, re la gore suffix ya rena always ke ene. Ge ile gore it was alkane, re tseba gore ke ane. So now because ke alkenes, re la gore ke ene, so re la gore mo ke tlo add ene. So re la gore this is butte 1 in, or botša gore re kry-a double bond in carbon number 1. So this is our name. In some other textbook by name in this way, which is still correct. I can say this is 1, and then carry butene. so it's only the same thing. Mo re no ba botša gore re kry-a double bond ya rena in carbon number 1, and then this is but ke this one ke root, how many carbons, and then this suffix ke the ending name which is ene, and then re la gore ke 1 butene. So ke nyaka gore o di tsebe in both ways, because you don't know in the exam ba ka go fa which name, ba ka itlisha in this way or in this way, and then ba wena o draw a compound. So tlo tshwana gore di tsebe kaofela. So this is our name, and then now re lebelele this one. Ge o ka lebelela this one, o ka kgona bona gore ba re file yona in the form of a condensed. Re discussed about the condensed in the previous video. So this one ba re file yona in the form of a condensed, because this CH nka engwala as CH2 because ena le 2 hydrogen. Re la gore ke tla ba ke ngwadile in the form of a condensed, but it's all the same thing. So more tlo dira the same thing. First re nyaka go identify the longest chain, but re nyaka gore that longest chain it contain double bond the closest. Let's see how counter from left to right. This is 1, this is 2, this is 3, this is 4, this is 5. O ka kgona bona gore double bond re kry-a in carbon number 4 ge re move from left to right. But now let's see ge re move from right to left. Re la gore this is 1, this is 2, this is 3, this is 4, and this is 5. So ka kgona bona gore our double bond re kry-a in carbon number 1 ge re move from right to left. So re la gore the right naming it tlo ba ya ge re move from right to left. So re la gore we can say this is 1, 2, 3, 4, 5, because ge re move from right to left double bond re kry-a early, so re kry-a in carbon number 1. So now let's name. Re tlo dira the same thing. Ke substituent, and then ya re root, and then ya re suffix. Arne substituent because arne branch in this case. So re la gore re tlo thoma ka root, and then re latela ka suffix. The root re nyaka the longest chain. So this number of carbons ke 5 ke the longest, and then 5 ke pent. So re la gore ke tlo re this is pent, and then re kry-a double bond in carbon number 1. So re la gore ke tlo re dash, and then ka re 1, and then ka re ene ke the suffix. Remember gore re discussitše gore a dash is separate a number and alphabet. As you can see, this is alphabet and this is a number. The same here, this is a number and this is alphabet, and then more beile a dash. So this is our name ke pent 1 in. Ge o rata o ka engwala in this way, where this is 1, and then ware a pentene. Remember gore o ka se separate pent le ene because kaofela ke alphabets. So this is our name, pent 1 in, or you can say 1 pentene. So now re lebelele the examples mo ile gore re na le substituent, mo ile gore re na le a branch. Let's see this one first. Ge o ka lebelela this one, re na le a branch, re na le a substituent. But first re identify the longest chain. Let's see ge re counter from right to left. This is 1, 2, 3, 4, 5, 6. The longest chain ya rena e fa gore ke 6 carbons. And then now let's count from left to right. This is 1, this is 2, this is 3, 4, 5, 6. Let's see ge le gore re choose another direction, ge le gore re tšea this direction. Re la gore this is 1, this is 2, this is 3, and this is 4. Re la gore this one is out because e re fa the shortest, because 4 and 6 e kgolo ke 6, and then rena re nyaka the longest chain re la gore ya 4 is out. And then now let's see this one. 1 2 3 4 5. Even this one is out because erfa the shortest. 5 and 6 the greatest is 6. So re la gore the right one yo ba ya 6 carbons. But now let's see gore ge re move from left to right le ge re move from right to left ke efeng e le gore re obtain a double bond early. Let's see ge re tšea right to left. This is 1, this is 2, this is 3, and on carbon number 4 re na le a double bond. And then now let's see ge re move from left to right. Ge re move from left to right, this is 1 and this is 2. Our double bond re kry-a in carbon number 2. Re la gore ge re ya in this way is 2, and then ge re ya in this way is 4. Re la gore the correct one it will be this one, because re nyaka gore double bond re obtain early. So re la gore now I can make the conclusion ka re the right one you over this one. 1 2 3 4 5 6. Re la gore this is our branch, and then rename from left to right. Now lemoga gore re na le a substituent in carbon number 4, because this is our substituent ke branch. This is our chain, and then more na le a branch, and then this substituent re kry-a carbon number 4. So re la gore ge re yo name roba specific. This is found in carbon number 4. And then now let's name. Re tlo dira the same thing. Re thoma ka substituent, and then re latela ka a root, and then re latela ka suffix. Now let's name. Ke tlo re na le 4-methyl. Re la gore now I'm specific. Ke tlhalosa gore in carbon number 4 ke na le a branch, and then that branch e na le 1 carbon. Re la gore it's methyl. And then now re nyaka a root. Ro lebelela gore our longest chain e na le how many carbons. This longest chain e re fa gore re na le 6 carbons. E re la gore now ke tlo re hex, because 6 ke hex. And then now re tlo tshwanela gore re be specific gore re kry-a ka double bond. A double bond re kry-a carbon number 2. So re la gore now ke tlo re dash and then ka re 2. Remember our dash is separate a number and alphabet. Mo ka lemoga gore a se ke be dash because kaofela ke di alphabet. So more because ke bile specific gore double bond ke kry-a in carbon number 2. E re la gore now ke tlo tshwanela gore ke ngwale suffix. Suffix ke the ending name, because this is alkene. E re la gore re tlo re ene. So this is our name, 4-methyl hex 2-ene. Let's see ge le gore re šomiša that other name. E re la gore ke tlo re this is 4-methyl, and then ka re dash ka re 2-hexene. So ka kgone bona gore ge re šomiša this name, this hex and this ene di ba close. So it's all up to you wena o name bjang. But what is important ke gore always the double bond o tlo tshwana gore o be specific re o kry-a ko kae. So now re lebelele this one. E re first re kry-e the longest chain. 1 2 3 4 5. And then let's see this one. 1 2 3 4 5. So ka kgone bona gore our longest chain is 5. Le go ka name in this way were 1 2 3 4 5. O tlo obtain the same thing. E re la gore the longest chain ke 5 carbons. But now let's see gore ke kae more obtain our double bond early. Ge re move from right to left, this is 1 and this is 2. Re obtain a double bond in carbon number 2. And then now let's see ge re move from left to right. This is 1, 2, 3. Re obtain a double bond carbon number 3. So 2 and 3 re la gore re tlo tšea priority ya 2. So re la gore re tlo tšea this direction. And then o ka kgona bona gore re na le a substituent in carbon 4. So now let's name. Re tlo thoma pele ka substituent. So our substituent ke methyl, and then re kry carbon 4. Re la gore ke tlo re this is 4 methyl. And then after substituent re tseba gore ke a root. Re na le the longest chain ya 5 carbons. So re la gore ke tlo re pent. And then now ke nyaka go ba specific ka double bond. This double bond re kry carbon 2. Re la gore ke tlo re dash and then ka re 2, and then now ra ngwala suffix which is ene. So this is the name. And then ge le gore re šomiša the other name, re la gore yo ba 4 methyl, and then dash war 2, and then war pentene. So that's it for this problem. And then now let's see this one. First, I find the longest chain. 1, 2, 3, 4, 5, 6. And then now let's count from right to left. 1, 2, 3, 4, 5, 6. So our longest chain is 6 carbons. If we go move in this direction, 1, 2, 3, 4. And this one is out. And then now let's see area on this one. This is 3, this is 4, this is 5, and this is 6. Still yona irfa 6 carbons. So now let's see what the yellow is correct. Let's use this one here, going from left to right and then going from right to left. Let's see where move in this direction or obtain a double bond in which carbon. This is 1, this is 2, and this is 3. Our double bond obtain a carbon number 3. Let's see where move from right to left. This is 1, this is 2, and then our double bond obtain in carbon number 3. So now either way our double bond recreate in carbon number 3. But now there is something very important. Only this situation, you don't say because I can move from left to right and then I can move from right to left is the same, so we cannot homa monyakao. It doesn't work like that. So now ro lebelela the branch gore branch ya rena re kry-a early ge re move in which direction. Now let's see ge re move in this direction. This is 1, this is 2, this is 3, and then more le branch, and then this is 4, and then this is 5, rena branch. Re la gore re kry-a branch in carbon 3 and 5 ge re move from right to left. So now let's see ge re move from left to right. Ge re move from left to right, this is 1, this is 2, re kry-a branch carbon 2, and then this is 3, and this is 4, re kry-a branch in carbon number 4. So now let's see what between these two is correct. Re nyaka the one you are the lowest number. ge o ka re 2 plus 4 e go fa 6, and then ge o ka re 3 plus 5 e go fa 8. So re la gore the correct one ke this one ge re move from left to right. So it's very important gore ge o ka kry-a gore double bond le kry-a in the same position, and then now o focusa on the substituent, and then o nyaka gore the substituent we kry-e early. So in this case re la gore the right naming yo ba ge re move from left to right. Re la gore this is 1, this is 2, 3, 4, 5, 6, and then re la gore this is our chain. So re la gore this is our branch, and then this branch go fela go bona gore ke methyl because di na le 1 carbon. So re la gore this is methyl and this is methyl. So this one re kry-a carbon 2, and then this one re kry-a carbon 4. So now let's name substituent, root, and suffix. So let's see gore our substituent re kry-a ko kae. Remember now re na le 2 substituent which is methyl. So re la gore tlo tshwanela gore be specific. So ke tlo re this is 2, comma, and then ka re 4. Ke tlhalosa gore ke na le substituent in carbon 2 and then in carbon number 4, and then because they are 2 re la gore ke tlo re di, and then ka re methyl. So re la gore now ke tlhalositse gore in carbon 2 and carbon 4 ke na le 2 methyl, that is why ke šomišitše di. And then now let's go to the root. The longest chain ya rena e na le 6 carbons, so re la gore ke tlo re this is hex, and then after here ka specify the double bond. Double bond re kry-a in carbon number 3, so re la gore ke tlo re dash, and then ka re 3, and then from there ka ngwala the suffix which is ene. So this is the name 2,4 dimethyl hex 3-ene. But now let's see re šomiša the other name. Re la gore this is 2,4 dimethyl, and then ka re 3, and then ka re hexene. So this is it. A re lebelele the last one. First re identify the longest chain. 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6. O ka kgona bona gore the longest ya rena ke 6 carbons, because le go ka counter in this way, this is 1, 2, 3, 4, 5, 6. So still rena le 6 carbons. But now what is important gore re identify mo re kry-ago double bond first, because double bond is always priority. So let's see. Ge re tšea this direction, re 1, 2, and then ra obtain a double bond. But now let's see ge le gore re tšea this direction. This is 1, 2, 3, 4. Re create double bond in carbon number 4. So re la gore it's out. Roger the one here, the shortest, which is 2. And then now lemoga gore re na le substituent. Re na le substituent here, and then ra ba le nngwe here, and then another one here, and then kaofela ke methyl. So re tlo tshwanela gore re di specify, and then because they are 3 re la gore e tlo ba try. And then now let's name. Ke tlo re 4.4 and then 0.5. Ke re la gore in carbon number 4 re na le substituent ke carbon number 4 re na le branch, and then again in carbon number 4 re na le branch, and then in carbon number 5 re na le branch again. So because they are 3 and then ke the same thing re la gore ke tlo re try, and then because ina le one carbon re la gore ke methyl, and then from there re tlo ngwala the root. Re na le 6 carbons re la gore ke tlo re this is hex, and then now ro specify a double bond. Double bond ke kry-a carbon 1 2 re la gore now ke tlo re 2, and then from there ka ngwala the suffix which is ene. So this is 4.4.5 and then trimethyl hex 2-ene. So we're now going to name our shumisha the other name. So that's it for this problem anyway. And then now let's see these two. Let's see this one first. The longest chain. Counter from right to left. This is 1, 2, 3, and 4. And then now let's see counter from left and then rear to the right. This is 1, 2, 3, 4. But Rakajia this direction again, this one, because Leona is a chain. So this is 1 and this is 2, this is 3, this is 4, and this is 5. Gargia this direction or obtain 4 carbons. Gargia this direction or obtain 4 carbons. But Gargia this one or obtain 5 carbons. So which one is correct? Remember the longest chain, but not just the longest chain. That longest chain it contain double bond the closest. So let's see in a double bond the closest. Lemoga counter in this way. This is 1, this is 2, this is 3, and this carbon number 3 in a double bond, and then 4, 5. So this direction or obtain a double bond in carbon number 3. So now let's see other options. Here from left to right, this is 1, this is 2, this is 3. So still area in this direction obtain 3. And then area from right to left, this is 1, this is 2, this is 3, and this is 4. Double bond obtain carbon number 1. For the reason arnali a option double bond it can be maintained early arogia that direction, even though this one irfa 5 carbons which is the longest, but for the reason obtain a double bond later compare another direction compare early, even this one is out. So the right naming yobaya remove from right to left this one, because this one remove from right to left a double bond recreate carbon number 1. So actually double bond is the main priority. And then morally the substituent carbon number 2, but this time around in a 2 carbons is ethyl. So now let's name substituent, and then this substituent ethyl is in carbon number 2. 2 ethyl. And then now let's find the root. Root the longest chain 4 carbons. Remember choose this direction because obtain a double bond early. So 4 carbons. So bute. And then now specify a double bond. So this double bond recreate carbon number 1. So 1, and then from there the suffix ke in. So this is the name, 2-ethyl but 1-ene. Ka kgona bona gore what is important ke the double bond. It's always the priority. A re lebelle the last one. Re check the longest chain. This is 1, this is 2, this is 3, 4, and 5. And then let's see this one. This is 1, 2, 3, 4, 5. Let's see this one. This is 1, this is 2, this is 3, this is 4, 5, 6. This direction requires 6 carbons, but move from left to right and right to left require 5. But this doesn't mean this one you are the longest chain. Re obtain a double bond early which direction. Move from right to left, obtain a double bond in the first carbon. Left to right, obtain a 1, 2, 3, 4. Obtain in carbon number 4. So this one is already out. And then still direction a double bond obtain in this carbon. Is late. So the correct naming moving from right to left. So this is our chain, and then this is our substituent. So now we can name. This is 2-ethyl because only 2 carbons. 1, 2 is 2-ethyl, and then only 5 carbons, which is pent. And then this double bond require carbon 1, and then from there the suffix is ene, and then this is the name. So now let's see this one. It's complicated, but I don't follow the rules, and then it will be simple. First, identify the longest chain. Count from left to right. This is 1, 2, 3, 4, 5, 6. And then let's see this one. This is 1, 2, 3, 4, 5, 6. The longest chain for 6 carbons. But let's see other directions. This one. Ranali 1, 2, 3, 4, 5, 6. So still require 6 carbons. And then let's see this one. This is 1, 2, 3, 4, 5, 6. So still require 6 carbons. And then this one. This is 1, 2, 3, 4, 5, 6. Actually, the longest chain is for 6 carbons. But now let's see what direction if obtain a double bond early. Let's see move from left to right. This is 1, and then this is 2. Obtain a double bond in carbon number 2, and then still in this direction double bond is carbon number 2. Actually moving from left to right carbon number 2. Let's see move from right to left. 1, 2, 3, 4. Obtain a double bond in carbon number 4. So now actually the shorter way more obtain a double bond early this direction, because you got to choose this one. This will be 1, 2, 3. Still Leona is long because already only 2. So consider here 2. so re la hore ke tlo tja this direction ya move from left to right, either ke ya in the straight chain or ke ya upwards, e sa le the same thing. So na ke tlo choose this one here straight. But now lemoga gore re na le substituents, re na le a branch here ya 1 carbon e rela gore is methyl, and then ra ba le branch here ya 1 carbon which is methyl, and then ra ba le another branch here, but this one ke 2 carbons rela gore is ethyl, and then this one 2 carbons rela gore it's ethyl. So now let's name. But because now re na le methyl and ethyl at the same time, re la gore ro lebella alphabetical order. It means ge re na le ethyl and then re na le methyl, re la gore E comes first, so re la gore ro thoma ka ethyl and then ra latela ka methyl. So let's see. Re na le ethyl in carbon 3 and then also in carbon 4. So re la gore ke tlo re this is 3 and then got a comma 4, and because ke ethyl J2 re la gore ke tlo re di, and then from there ka re ethyl. So now re tlo ngwala methyl. Methyl re obtain carbon 2 and also carbon 5. So re la gore from there ke tlo re dash and then got 2 and then got comma 5. Remember comma is separated the number, and then because this methyl ke J2 ke tlo dira the same, and then got dash got di, and then got methyl. So now because re ngwadile the substituent re tlo lebelela the root. Our longest chain e re fa gore na le 6 carbons, so re la gore 6 ke hex, so ke tlo re a hex, and then now re tlo specify the double bond. This double bond ke obtain in carbon number 2, so re la gore now ke tlo re 2, and then from there ra add the suffix ene, so re la gore this is the name. And that's it for this question. And then now let's see this one. This one o ka lemoga gore re na le 2 double bond, but the rule remains the same. What is important re nyaka the longest chain that contains the double bond. So re la gore re tlo counter from the direction ye le gore re obtain this double bonds early. So let's see ge re counter from left to right. This is 1, 2, 3, 4, 5, 6. The longest chain in only 6 carbons. But now let's see what we obtain a double bond guy. This double bond we obtain in carbon number 1, and then this one we obtain in carbon number 4. So this is 1 and 4. And then now let's see the other direction. Re move from right to left. Re move from right to left. This is 1, 2, 3, 4, 5, 6. Re obtain a double bond in carbon 2 and then also in carbon 5. So now let's see what ke is correct. Re this direction, re 1 and 4, and then re this direction, re 2 and 5. So which one is correct? 1 plus 4 for 5, and then 2 plus 5 for 7. So re got the lowest number. The correct one is this one. Re this direction. So now we can make the conclusion the right direction ke moving from left to right. This is the right direction. And then this is carbon 1, carbon 2, 3, 4, 5, and 6. So this time around RNA a substituent. So now let's name. Remember re thoma ka substituent, and then re latela ka a root, and then re latela ka suffix. So now because RNA substituent re la gore ra thoma ka root. Root re nyaka go tseba gore re na le how many carbons tja the longest chain. The longest chain re na le 6 carbons. So now let's name. Re la gore ke tlo re hex, but ke nyaka gore ko share something. Ge re na le double bond J2 re ba le what we call the euphonic. So every time ge re dila le euphonic on the root always re add a re la gore this is going to be hexa. Ge be o na le but o bo tlo add a and then ya ba buta. Ge be le gore o na le pent o bo tlo add a ya ba penta. So always ge re na le the double bond J2 re la gore re na le what we call the euphonic. So re add a. So re la gore this is our root. So now let's go and specify the number of double bond. Re kry-a double bond in carbon 1 and then also in carbon 4. But because this double bond ke J2 re la gore re tlo ngwala di, and then from there the suffix ya ba ene. So re la gore this is the name, a hexa 1.4 diene. So remember gore are separate this e le this di because kaofela ke di alphabet. So this is the name. What is important gore ge re na le the euphonic re add a at the end. So that's it for this question. Let's see this one. Even this one o ka lemoga gore re na le a double bond. Re na le a double bond here and then a double bond here. So first re count these carbons. We count from right to left. Re la gore this is 1, 2, 3, 4, 5. And then let's see what we obtain a double bond guy. We obtain a carbon 1 and then also carbon 3. So this is 1, 3. And then now let's see other directions. We move from left to right. This is 1, 2, 3, 4, 5. We obtain a double bond, carbon 2 and then also carbon 4. Ge o ka tšea this direction ya go ya fase, you will realize gore this is 1 and then this is 3. So re la gore actually this direction, even this one e re fa 1 and 3. So now let's see gore which one is correct. Ge re ya in this direction re kry-a 2 and 4, but ge re ya in this direction re kry-a 1 and 3. Remember gore ge le gore o nyaka o tšea this one re la gore this is carbon 1, this is carbon 2, carbon 3 and carbon 4. Re la gore mo ke 2 and 4. So o ka lemoga gore 2 and 4 it's out because 2 plus 4 ke 6 and then 1 plus 3 ke 4. So the lowest ke ya 1 and 3. So re la gore the right direction ke this one ya 1 and 3, and then re obtain le ge re ya to the left. So re la gore this is our chain, and then re la gore this is our branch. So now let's name. As usual re tlo re a substituent and then ra re root and then suffix. This time around re na le substituent, so re tlo tshwanela go re specify. Re find in carbon number 4. So re la gore ke tlo re this is 4 and then ke tlo re methyl because ke carbon and hydrogens. So ke tlo re 4 methyl, and then now re are to a root. The longest chain re fa gore na le 5 carbons, and then 5 e rela gore ke pent, but because mo re na le the euphonic re na le double bond J2 e rela gore instead of saying pent ke tlo re penta. So re rela gore now this is penta, and then from there ke tlo specify the double bond. Re kry-a double bond in carbon 1 and 3. Re rela gore ke tlo re this is 1 and then ka re 3, and then because ke J2 re rela gore ke tlo re die, and then from there the suffix in. So this is the name. It's not difficult at all. What is important go wena o gopole this part here, a penta, and ska dira phoso about the numbers and the dash. Ra tseba gore a dash is separate a number and alphabet, and then comma is separate the number. So e ka so palele go ka gopola in that way. And that's it for this question anyway. So now let's take this name and then draw a structure, because in the exam sometimes you might be given the name and then we now draw a structural formula, a condensed or a molecular. So now let's take this name and then draw a structural formula, condensed and molecular. So what is important first, ko gopola gore this name re obtain from substituent, root, and then the suffix. Re la gore wena o lebelela this name in 3 parts. Re la gore this part ke the substituent, and then this second part re la gore ke the root, and then re tseba gore the root e re botsa ka the number of carbons, and then this suffix ya ene e re botsa gore di la le alkene, and then re tseba gore this number e re botsa ka position ya a double bond. So wena first o focus on the root. Root e re botsa ka the number of carbons, so more our root e re build re la gore e na le 4 carbons, so ono thoma le gore 1 2 3 4, and then from there one name your carbons. Gore choose which direction, it's all up to you. So now go choose this one. This is 1 2 3 4, and then from there kaya ka lebelela at the substituent. The substituent ba re na le 2 methyl, eno re la gore in carbon number 2 re na le branch, and then for the reason ya gore ke methyl e re la gore that branch e na le 1 carbon and hydrogens, e re la gore ko ya carbon number 2, and then remember this is a structural, re bontšha all bonds and hydrogens. So this is our branch, and then now re na le a double bond in carbon number 1, re la gore ke carbon number 1 and then ka ngwala double bond. So this is carbon number 1, re la gore mo ke na le a double bond, and then from there ka kgona bona gore all that is left and over go add the hydrogens. So re la gore go add the hydrogens. Remember gore a carbon can only be surrounded by the maximum of 4 bonds, so be careful. This one if a ledge in a 4 bonds, o skebe wa add another hydrogen here, because o tlo ba le 1 2 3 4 5, and then automatically it's wrong. So be careful. A carbon can only be surrounded by the maximum of 4 bonds, and then because this one in a 2 bonds, re la go add 2 more, so I can add here or here. Remember it doesn't matter or add go kae, ge o rata o ka no add here, because at the end re na le 4 bonds, 1 2 3 4. So now re la gore this is our structure and then it's village. And then now let's draw a condensed. Condensed is very easy, remember. What is important? Ro lebelela this carbon in a two hydrogens. This is CH2 because in a two hydrogens. And then now raya on this carbon. This carbon in a branch. So because in a branch, go bula a bracket, and then kangwala this branch. Get one carbon and then in a three hydrogens. This is CH3. And then refedi cheka this one. And then now let's see this one. Get one carbon in a two hydrogens. So C and then carry H2. And then as for this one, in a three hydrogens. This is CH3. And then this is our condensed structure. What is important a branch, a substituent, represent a bracket next to that carbon. So this is our condensed. And then now let's see a molecular. A molecular is straightforward. Remember the number of carbons and the number of hydrogens. Let's see here the total number of carbons. This is 1, 2, 3, 4, 5. So arnale 5 carbons. Then I will say C5. And then let's add these hydrogens. These hydrogens required add ka ofela di tlo fara ke 10. So arnale H10. So this is your molecular formula. And remember molecular formula ka khona shumisha the general formula. Remember alkene in this general formula ya CnH2n. And then this n represent the number of carbons. So because these carbons they are 5, I will say this is C5. And then H2 n number of carbons and then get J5. So from there only C5, 2 times 5 get 10. This is H10. So either way look the same answer. But what is important to tell your question is drawing a condensed, a structural, or a molecular. A molecular in this way, and then a condensed, it's in this way, and then a structural, all bonds, and then all hydrogens. And then when all that you can do now, clear all those names, and then when I draw the structure, because already are the structures. When I know those names, and then we'll find out the structure, and then we'll relate the condensed and the molecular. So that's it for this tutorial anyway.